I want to start with something honest. Most health content online makes your body sound broken, like you need the right supplement, the right program, the right expensive intervention just to function normally. But what if your body was never broken? What if it's been trying to repair itself this entire time, and the only thing standing in the way was something you were doing every single day without realizing it? Because there is a process already built into every cell you have that cleans out damage, burns the fat your body has been hoarding, and essentially rebuilds you from the inside out. It takes 24 hours to fully activate. A Nobel Prize was awarded for discovering it. And by the time this video ends, you'll understand exactly how to switch it on. Let's talk about it. The Japanese scientist who changed how we understand the human body. In 2016, a quiet and somewhat understated Japanese scientist named Yoshinori Ohsumi stood in Stockholm and accepted the Nobel Prize in Physiology or Medicine. He wasn't a celebrity researcher. He hadn't developed a blockbuster drug. He'd spent the better part of his career studying yeast cells, which, as you might imagine, is not the kind of work that typically makes headlines. But what he found inside those yeast cells turned out to apply to every living thing on Earth, including you, including me. He discovered that cells, when deprived of incoming nutrients, don't just sit there and wait. They get to work. They begin systematically identifying and dismantling their own damaged parts, broken proteins, worn-out cellular machinery, accumulated debris that had been building up for years. All of it gets tagged, collected, broken down, and recycled into fresh, raw material. Ohsumi called this process autophagy, from the Greek autos, meaning self, phagon, meaning to eat. Your cells, quite literally, eat themselves clean. And here's where it gets personal, because this isn't just cellular housekeeping. When the cleanup crew finishes, when the damaged material has been cleared away, what happens next is the part that genuinely surprised the researchers who studied it. The body uses those recycled materials to build new stem cells. Not just repair old cells, generate entirely new ones. A team at the University of Southern California, led by longevity researcher Dr. Walter Longo, measured stem cell regeneration during extended fasting periods, and what they found was, in their own words, remarkable. Regenerative activity in certain cell populations reached levels up to 1,000 times higher than normal baseline measurements. 1,000 times! Not a modest improvement, not a percentage point or two. 1,000 times the normal rate of cellular regeneration triggered not by a drug, not by an injection, but by the deliberate, temporary absence of food. And simultaneously, while all of that regeneration is happening, your body's doing something else entirely. It's finally burning the fat it refused to touch before. Why your body refuses to burn certain fat. Let me make this personal for a second. Have you ever eaten well for weeks? Genuinely well exercised consistently? Done everything you were told and still found that a specific layer of fat, usually around your midsection, simply refused to move? There's a biological reason for that, and it has a name: insulin. Every time you eat anything, any food, any amount, your pancreas releases insulin into your bloodstream. Insulin's job is to manage blood glucose, to ferry sugar from your blood into your cells where it can be used as energy, and to store whatever isn't immediately needed as fat. That's the job everyone knows about. Here's the job almost nobody talks about. Insulin is also the biological lock on your fat cells. When insulin is present, even at relatively low levels, a specific enzyme called hormone-sensitive lipase, which is responsible for releasing stored fat into the bloodstream to be burned, is directly suppressed. Switched off. As long as insulin is circulating, fat stays exactly where it is. And autophagy? Also suppressed by insulin. The cellular cleaning crew is sent home the moment food arrives. Researchers at the Salk Institute tracked eating patterns in a large group of adults and found something sobering. On average, people were eating across a 15 to 16-hour window every single day. That means for 15 or 16 hours out of every 24 insulin is elevated. Fat burning is blocked. Autophagy is off. Your body's most powerful healing system operates in the narrow windows between meals, and most of us have almost entirely closed those windows without realizing it. So what happens when you deliberately open that window and hold it open long enough for your biology to shift into a fundamentally different gear? That's the 24-hour protocol. And I want to walk you through it hour by hour because the timeline is where this stops being abstract and starts feeling real. What actually happens when you go 24 hours without food? Most people imagine fasting as one long, uniform stretch of hunger. It isn't. It's a sequence of distinct biological phases, each one building on the last. Hours 0 to 4. The settling. Your last meal is finishing its journey through your digestive system. Insulin is still elevated but declining. Blood sugar is normalizing. Your body is still running on what you just ate. Nothing dramatic yet, but the clock is running. Hours 4 to 8. The unlock. Insulin crosses below a critical threshold. Something shifts. Hormone-sensitive lipase activates, and fat cells that have been locked for hours begin releasing stored fatty acids into the bloodstream. Your liver picks up these fatty acids and begins converting them into ketone bodies, a fuel source your brain runs on remarkably well, often describing a clarity and steadiness of thought that glucose burning rarely produces. This is real fat burning, not the modest metabolic effect of skipping a snack. Direct release of stored body fat, including the visceral fat packed around your organs, into your bloodstream to be used as fuel. Hours 8 to 16. The cleaning begins. A protein complex called mTOR thinks of it as the grow and build signal inside every cell begins to quiet down. As mTOR drops, autophagy starts switching on. Cells begin tagging their damaged components, worn-out proteins, dysfunctional organelles, accumulated debris with a molecular flag that marks them for recycling. Specialized structures form around this tag material and deliver it to the cell's own internal processing unit to be broken down. Your body is cleaning the house, room by room, cell by cell, simultaneously throughout your entire body. Hours 16 to 24. The regeneration. This is the window that earned Ohsumi his Nobel Prize. This is what Longo's team at USC spent years documenting. Autophagy reaches what researchers describe as deep activation. The cleaning has become a renovation. Stem cell production, particularly in the bone marrow and the gut lining, begins accelerating in ways that surprised even the researchers measuring it. Your immune system is literally discarding old, damaged immune cells and replacing them with fresh ones. A process one research team described as the closest thing to an immune system reboot they had observed in a non-pharmaceutical context. And the fat burning? Still accelerating. Ketone levels are high. Inflammation markers are dropping. Many people report that this is the phase where the hunger they expected simply lifts, replaced by something closer to a quiet, clear energy they hadn't anticipated. 24 hours. Your body did all of that. It was always capable of it. It just needed the space. What the Nobel Committee understood that most people still don't? There's a detail about Ohsumi's story I find quietly profound. He was studying a process that human beings had been practicing instinctively, culturally, spiritually for thousands of years before a single scientist put a name to it: religious fasting. Seasonal food scarcity, the natural rhythm of eating that existed before the modern world made food available at every hour of every day. Ancient cultures prescribed periods of not eating not because they understood cellular biology, but because they observed across generations that people who practiced it seemed to age differently, recover faster, stay sharper longer. Ohsumi didn't invent autophagy. He revealed it. He gave us the language to understand something the human body had been doing and benefiting from since long before we had the tools to see it happening. What's changed is that we now live in a world that has almost completely eliminated the conditions that trigger it, not through malice, through abundance. And perhaps the most important thing we can do with Ohsumi's discovery is simply create those conditions again, deliberately, periodically, one day at a time. The protocol, plain and simple. Here's the good news about the actual protocol. It's simple, genuinely simple. The complexity is all in the biology we just walked through. The practice itself is straightforward. The basic approach. Pick your window. The most manageable version? Finish eating dinner at 7 p.m. Don't eat again until 7 p.m. the following evening. You sleep through the first 8 hours. By the time you wake up, you're already a third of the way through. What you can have? Water as much as you like. This is non-negotiable. Black coffee, interestingly, a study published in the journal Cell Reports found that coffee actually appears to enhance autophagy rather than disrupt it. Something about its compounds seems to complement the process. Plain herbal tea is fine. Electrolytes, sodium, potassium, magnesium with no calories. After hour 16 especially, these matter. What breaks it? Anything with calories, including things people commonly assume are safe: bone broth, cream and coffee, a small handful of nuts, a protein supplement. Even modest protein intake activates mTOR and pauses autophagy. If the goal is the full 24-hour benefit, nothing with calories until the window closes. The mistakes worth knowing about. Breaking the fast with a large carbohydrate-heavy meal produces a dramatic insulin spike, ironically blunting some of what the fast created. Break it instead with protein and healthy fat first. Eggs, fish, avocado. Let carbohydrates come in later. Doing this too frequently without recovery isn't the goal. Once or twice a month appears to be the research-supported sweet spot for most healthy adults. This isn't a daily practice. It's a periodic biological reset. Ignoring electrolytes after hour 16 leads to symptoms of dizziness, headaches, muscle cramps that most people misinterpret as hunger. They're not. A pinch of sea salt in water resolves them within minutes. Attempting this with certain medical conditions, particularly diabetes, insulin-related medications, or a history of disordered eating, requires a conversation with your doctor first. The hormonal changes involved are real and significant. This is not a disclaimer to skip. You now understand autophagy not as a trend or a buzzword, but as a precisely mapped biological mechanism that earned its discoverer the highest scientific honor in the world. A process your body has been capable of your entire life, that most modern habits accidentally suppress around the clock. You understand why insulin is the master switch and why the 15 to 16-hour eating windows most people live inside keep that switch in the wrong position for the majority of every day. You walk through the hour-by-hour biology of what a 2-4-hour fast actually produces inside your cells, from the first unlocking of stored fat at hour 8, through the onset of cellular cleaning at hours 12 to 16, to the deep regenerative activity that researchers measured in stem cell populations during hours 16 to 24. And you have the actual protocol, what's allowed, what breaks it, and the 4 specific mistakes that undermine the very window you're trying to open. There's one more piece I didn't get to today. The hours immediately following the end of a 2-4-hour fast, roughly the first 4 to 6 hours, are what researchers are beginning to call the anabolic rebound window. Your stem cells are maximally primed. Your cells are hungry for specific raw materials. And the foods you choose in that window, or don't choose, have a disproportionate influence on whether the regeneration that happened during the fast actually gets locked in and built upon, or quietly fades before your next meal. There are 3 specific foods that appear based on current research to have the most meaningful impact during this window. Foods that essentially hand your newly regenerated cells exactly what they need to continue the work your fast started. We're covering all 3 in the next video, along with the timing, because when you eat them matters almost as much as what they are.